This is the latest model of the B-2 Spirit US. This model has new winglets and an improved propulsion system that allows it to fly further without refueling. Let's take a look at this in more detail. It's me, and this is air power. Northrop Grumman's B-2 Spirit is one of the most advanced aircraft ever built. With only 21 examples in existence, the Spirit is an incredibly expensive platform with a per-unit flying cost of over $120 million. But despite its exorbitant price tag, the Spirit is also one of America's most capable bombers. And in some ways, the low observable or stealth characteristics of this plane are actually superior to newer designs like the forthcoming B-21 Raider. The Spirit entered service back in 1989 and was developed to penetrate heavily defended airspace in order to deliver both conventional and nuclear payloads deep into enemy territory. In fact, the B-2's original mission was to penetrate the Soviet Union's airspace undetected and strike high-value targets such as missile silos. These days, the B-2 is still primarily a strategic bomber designed to penetrate well-defended airspace. But its missions have expanded to include a variety of roles, including intelligence gathering, surveillance, and even close air support. One of the reasons for this expansion in mission set is the plane's incredible versatility. The B-2 can carry a variety of both kinetic and non-kinetic payloads depending on the mission. This includes joint direct attack munition, guided bombs, joint standoff land attack munition, cruise missiles, lightning targeting pods, and even the massive AGM-183, a tactical Tomahawk land attack missile, which is usually launched from the Navy's cruisers and destroyers. As part of its continued evolution, the B-2 will soon be equipped with the AGM-183AS air-launched variant called the Skyborg, which will allow B-2 South to strike targets deep within enemy airspace, without risking the lives of aircrew. This is made possible because the B-2's two-person crew can actually leave the aircraft unattended during certain phases of flight. You heard me right. A fully loaded B-2 can fly entirely without a crew on board. Here's how it works. During certain parts of its mission profile, the B-2 can go from a stealthy, low observable configuration into a more radar reflective configuration known as a bat out of hell mode. In this mode, the aircraft loses much of its stealth characteristics and flies with a very high wing loading. This results in a top speed that can exceed Mach 1.2 or around 900 miles per hour. Now I should note that the B-2 is untechnically a drone in the traditional sense, because it requires human control to operate. But the way that this aircraft can fly autonomously for periods of time means that it shares some similarities with today's unmanned systems. In fact, the B-2's autonomous capabilities were tested back in 2008, when a B-2 flew from Edwards Air Force Base to Guam without a crew on board. At the time, this was the longest drone flight ever conducted by the U.S. military. These types of advanced, autonomous operations aren't all that uncommon for the B-2 these days. And the crews who fly these aircraft spend a lot of time in the simulator training for their missions. In fact, just last year, Air Force B-2 pilots racked up over 1,000 hours in simulators training for potential operations against China. But what is even crazier than the B-2's autonomous operation capabilities is the amount of technology that this plane carries on board to accomplish its missions. The B-2 contains an onboard high-performance computer, along with a number of sophisticated electronic warfare systems. It also carries an advanced fire control stabilization system that's housed in a single pod above the forward fuselage. This system provides a means of acquiring and tracking targets while the aircraft is flying at very low altitudes. Now this aircraft really is the definition of form following function. Take a look at the sheer size of those engines, and then consider the fact that they need to produce enough thrust to lift a wingspan that save almost 175 feet across. In fact, the B-2's low aspect ratio wings are some of the largest on any operational aircraft today. They are swept at a variable angle, and they are designed to produce lift at very low speeds. This, combined with the B-2's high wing loading, gives this aircraft incredible short field performance. In fact, the B-2 can take off and land in very short distances. In fact, the B-2 can take off in less than 1,000 feet and land in less than 500 feet. In comparison, an F-35A needs about 4,000 feet to take off and 2,000 feet to land. That's 8 times more than the B-2. It can do in a fraction of the distance. To put it another way, the B-2 could take off and land in the parking lot of Radio City Music Hall in New York City. To make things even more impressive, the B-2 can fly continuously for 45 hours if need be. It does this by using its 3 auxiliary center tanks, which sit just ahead of the wing's leading edges. These center tanks increase the B-2's internal fuel capacity by about 50%. The B-2's range would be even greater if it were UNT for the weight of its propulsion system. Now, ironically, the B-2's engines are one of the major factors limiting the aircraft's range. But they're also the reason that it's able to take off in such short distances. The 80,000 pounds of thrust produced by these 2 massive engines allows the B-2 to take off with a very high angle of attack. This means that the B-2's steep approach and takeoff profiles result in very little ground loss, which allows the B-2 to operate from austere airfields or even improvised runways. But, as I mentioned earlier, this high thrust comes at a cost. If lighter engines had been used on the B-2, its range would have been significantly greater. To get around this limitation, Northrop and Boeing, who partnered together to build the B-2, added auxiliary center tanks to the design. These tanks not only allow the B-2 to reach its maximum range, but they also allow the plane to carry additional weapons or equipment. The B-2's long-range capabilities are important because they allow the aircraft to reach its target without having to stop for fuel. In fact, the B-2's long range is so great that it can circumnavigate the entire globe without landing. It does this by flying from its primary operating base in Missouri to its secondary operating base in Guam. From there, the B-2 can fly anywhere in the Pacific Theater without having to refuel. If the B-2 were to ever use this capability in a combat scenario, it would likely do so by conducting a low-level transit to avoid detection by enemy radar. In fact, the B-2's ability to fly at very low levels is one of the factors that makes it such an effective bomber. By staying below the horizon, the B-2 is difficult to detect and track, making it ideal for penetrating heavily defended airspace. In addition to its low-level penetration capabilities, the B-2 also has the ability to fly at high altitudes. This allows the aircraft to avoid both ground-based and airborne threats, making it a very survivable platform. In fact, the B-2's low observability and high survivability make it one of the most potent bombers in the world. I mean, we don't know exactly how stealthy the B-2 is, but we do know that it was considered to be the most stealthy aircraft in the world when it first entered service. Even today, the B-2 is widely regarded as being one of the stealthiest bombers in operation. And it's likely that its stealth characteristics are actually superior to the upcoming B-21 Raider. You see? The Raider was designed to make use of the advances in stealth technology that have been made since the B-2 was first built. But as it turns out, those advances in stealth technology have mostly come in the form of better materials and manufacturing techniques. So basically, the Raider is going to be faster, higher flying, and longer ranged than the B-2. Which makes sense considering that it was designed to replace the B-2. But ironically, the B-2 is still going to be more stealthy. Go figure. But the Raider will make use of other technologies that have advanced since the B-2 was in development, such as more powerful propulsion systems and better avionics. So, despite the fact that the Raider will be less stealthy than the B-2, it will be a more capable aircraft overall. The B-2 may be old by aviation standards, but it's still one of the most advanced aircraft in the world. With its long range, low observable characteristics, and high payload capacity, the B-2 is a formidable weapon that can be used for a variety of missions. And now with the addition of new winglets and an improved propulsion system, the B-2 can fly further than ever before without refueling, making it an even more potent force multiplier in future conflicts.